In your book, if you will turn to page 73, we're going to look at pages 73 through 76 today to talk about how the atomic theory developed over time, because this began really long time ago as people started to think about matter and its properties. I want you to think for a second that if you took, a chunk of silver or gold or lead or something like that, and you took that piece and you broke it in half, and then you took that half and broke that in half, and then you took that half and broke that in half, and you continue to do this over and over, eventually you would get to the very smallest, tiniest piece of that you could not break anymore. So the very smallest piece of something that can exist and still be that something is what we call an atom. So an atom is the smallest particle that can still be considered an element. So let's say the element is gold. You keep breaking it in half, you get to the very smallest piece, and that's what we call an atom. So those are the building blocks of all matter. The person who sort of named this was Democritus, was his name. Back in 430 BC, he was a philosopher, and he's the one who first proposed and said that if you took matter and began to cut it into smaller parts, eventually you would get to this very smallest piece that was uncuttable. You couldn't cut it anymore, and the term for that was atomos, and that's where he came up with the name for atom. Many years later, in about 1803, a scientist named John Dalton, who was an English chemist, wrote down what we knew at that time about atoms and came up with the theory, or Dalton's atomic theory. Whoops, that's not what I wanted to do. Came up with Dalton's atomic theory. And these are the highlights of that. So all elements consist of atoms that cannot be divided. All atoms of the same element are exactly alike. They have the same mass. Atoms that are different elements have different masses. An atom of one element cannot be changed into an atom of a different element. So you can't use a chemical reaction to turn gold into lead or silver into gold. And that compounds form when atoms of more than one element combine in a specific ratio. Those were his ideas back in 1803, and those still hold true for today. The idea was further expanded upon. It looks like about 1897. Thomson, who was one of Dalton's students, J.J. Thomson, came up with sort of some important information about the atom, and he actually discovered the electrons. So he discovered that atoms contain negatively charged particles called electrons. But they knew that these negatively charged particles were there, but they also knew, though, that atoms had no charge. So if there were negative particles that were there, and the atom itself didn't have a charge, that meant that there had to be some positive charges there someplace as well. So he reasoned that the atoms must also contain some sort of positive charge, and that this positive charge must balance out the negative charge of the electrons. So he proposed the model that we see here. They reference it and say that it's kind of similar to a watermelon, meaning that the electrons are like the seeds, and they're embedded in this mass of stuff that would be the positive material in the atom. This is often referred to as the plum pudding model when people write about science, meaning that the positive stuff is like the pudding or the bread, and the electrons are like the raisins that are sort of spread out through everything. Then another scientist in 1911, one of Thomson's former students, Ernest Rutherford, found evidence that sort of challenged that model. So this is famously called the Rutherford's gold foil experiment, where the scientist basically took this very thin sheet of gold foil, and they sent this electrically charged particle through the sheet. So you can almost think like X-rays in a way. And they expected that these would simply just pass through relatively straight, that the beams would just pass through to the other side, that some of them, if they got close to the positive center being an opposite charge, that they might get refracted or bent just a little bit to the side. And that's mostly what they found. Most of those beams passed straight through the foil. Others, however, had this really sharp ricochet and bounced off to the side, or they would go through and then they would bounce very sharply in one direction or the other. So based on that experiment, Rutherford suggested that the atom is mostly empty space, but it has a positive charge at its center. So instead of Thomson's model, which says that it's, all kind of together, that you have this positive stuff and you have these electrons embedded in it, instead, Rutherford suggested that it was mostly empty space. And that within that empty space is where the electrons were. So Rutherford inferred that the atom's positive charge must be packed within a very small region in the center, and he called that the nucleus. So Rutherford is the one who sort of named and found the nucleus of the atom. These positive charges, or these positive particles, then he called protons. So Rutherford is the one who basically discovered the nucleus of the atom and determined that the positive charges were very tightly packed within that. And then the negative charges, or the electrons, were sort of whirling around outside of that. In 1913, another scientist changed that idea a little bit. Niels Bohr, who was a Danish scientist, in around 1913 revised that atomic model again, and he suggested that yes, there is this nucleus, but instead of the electrons just sort of rolling around out there, they're actually in orbits, and they circle around in these very fixed positions with a fixed amount of energy. And we still use this Bohr model to represent atoms when we're kind of drawing their structure, and we'll be doing this a little bit later. So it's not, it's not that it's inaccurate by any means, but over time, scientists have revised this yet again, and they think that the atom probably looks more like this. And now we tend to think of it in more terms of what's called the cloud model. So in the cloud model, the electrons don't orbit around like planets around a sun. Instead, they're just moving very rapidly within this space that we call the cloud. And electrons' movement is related to the amount of energy that it has, and that is what's called the energy level. It's the specific amount of energy, and the electrons at different energy levels are likely to be found within different places within that cloud. So this model has changed over time from, scientists originally thinking that it just looked like a little marble, a solid ball, basically, to saying that it was sort of this solid thing that had a mostly positive center and there were negative things embedded in it, to saying that no, it's mostly empty space with all the positive stuff being at the very center in a very small amount of space and the electrons kind of being outside of that, to being able to represent those electrons being in very likely places within these different energy levels. Okay, we're going to stop it there today. So I would like for you to go back through 72 through 76 and answer all of the in-text questions if you did not do that in class the other day. And then tomorrow we'll carry on 77 through 79 and talk about the electrons and the protons and the neutrons and the nucleus of the atom in a little bit more detail. So come back for that tomorrow and have a great rest of your day.